For Darren Bruner, life at St. X began the way it does for many underclassmen. He was trying different things, searching for his place in the school. He even spent some time with WSTX.
I really didn't know what I wanted to do. Didn't feel like I was capable of doing much else except playing in my rock band. And I distinctly remember it was high school geometry where I first started to understand numbers and how they could actually be a little fun. It's not just crunching equations; it's figuring out volumes and shapes and patterns. And what really just unlocked the art of the possible for me was Miss Morgan's AP physics class. Because when I took that, I'm like, whoa, I'm not just taking derivatives to just find an answer for no reason. The age-old question people always ask is, when will I ever use this? Well, that's how you use it. You use it to find, the derivative of distance is velocity, and if you start to understand these equations and apply them to the physical world, you can build rockets.
Darren went on to graduate from St. X in 2013 and studied mechanical engineering at Speed School. He later spent some time in the oil and gas industry in Houston. It was down there that he found his true calling.
When I was down there, I found that I hated working in 100-degree humidity on a rig, but I did get the chance to tour the NASA Johnson Space Center, which is the hub of all human space flight for our country, and fell in love with it. It's just like that passion and that possibility of changing the world really struck me.
From there, he pursued a master's degree in aerospace engineering at the University of Colorado Boulder. His emphasis was on bioastronautics.
It's a fancy word for the study and support of life in space. So I took courses like space habitat design, space physiology, what happens to the body in space, and how do you protect against all the bad things, radiation, things like that.
Taking a job with Lockheed Martin, Darren began work on the Orion crew capsule. Orion sits atop the Artemis moon rocket, the most powerful rocket ever launched.
3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
But his work is in life support, and this is an unmanned mission.
This one's uncrewed. It's a test flight of the system before we put people on board. So there's very, very little life support actually, just like thermal, because our computers and electronics get really hot. So ECLIS, that's my team, the environmental control and life support. We do need to make sure all the heat from our electronics are cooled and that the vehicle is pressurized, because we don't want it to explode or implode, obviously. So that's the two things that I do have a piece in with this one.
His real job with the program won't kick into gear until the second launch of the rocket, where there will be people on board.
I integrate and test all of the life support elements on the spacecraft. So that's oxygen, nitrogen, water, food, yes, waste. I'm a software hardware integrator. So I'm neither a software engineer or a hardware engineer. I'm a systems engineer, and I need to know a little bit of both. So the software team will write up this code that says, here are all the possibilities. And I can barely read it. I mean, it's super complicated. And it's basically all the possibilities that the software can do to operate our spacecraft. And then the hardware team will give me this box and say, it can run all these commands if spoken to. Okay, well, what are we actually going to do in flight? We're going to spin those fans up to a certain speed to meet our requirements. We're going to flow those pumps at a certain flow rate to meet our requirements, etc. So I am the one that makes that software talk to the hardware for the first time in our Denver lab. And if that software is, the bugs are ironed out, and I find bugs a lot, I'll speak to the folks on either the software or the hardware side, find a solution, fix the defect, and iterate. And then once that software is deemed good, it'll get uploaded on the real vehicle down here in Florida. The other thing I'm doing right now is building crew displays. And I wish I could send you some pictures, but I think it's classified at this point. But it's basically the interfaces that the crew will use on their screens. I'm doing this because they have little toggles. Fun fact, a lot of people are like, why don't we have touch screens in space right now? I mean, our displays look like 80s technology. Because the crew wants to be sure that if they say eject, I don't think there's actually an eject button, but I'm just saying, a dangerous command, that they definitely want to hit that command. You have a big fat glove on, I mean, hopefully a good engineer wouldn't put the eject button right next to the thermostat, right? But say they did, fat finger it, you press the wrong button. The crew wants to feel the hard switch, temp down or something like that. They touch screen, so that's another example of over engineering, or better is the enemy of good enough. So I'm building those displays right now that the crew interacts with to fly the vehicle from a life support perspective.
Don't call him a rocket scientist, though. Darren will quickly correct you.
I am not a rocket scientist, although a lot of people joke about that. I work on the life support, so I know enough to probably give you a good enough answer. I'm like the space plumber.
Whether he is an engineer, a plumber, or a scientist, one thing is for certain. St. X is quite proud of our rocket man.
At every institution I've been a part of, Lockheed, folks at Lockheed, mentors here, grad school, undergrad, and St. X hands down was the biggest influence in my career. If I didn't have faculty that believed in me, pushed me, drove me, I don't know where I'd be. Not here. The rest was just kind of an extension of that.